So let's move on to LCM now. So what is LCM? In HCF, remember, we were given the dividend and we were trying to find the divisor. In LCM, the reverse happens. You are given the divisor and you try to find the dividend. That means you have the smaller number and you find the larger number. So if two numbers, natural numbers x and y, the least natural number which can be divided by both x and y completely is called the LCM. So these two numbers are the divisors. Okay. And the least natural number which can be divided, that means you are finding out the dividend. Okay. For example, let's take the same example that we had taken earlier, 20 and 25. Okay. Now 20 and 25, what is the smallest number through which both of them can be divided? Both of them can be divided. That number will be 100. 100 can divide 20. 100 can divide 25 also. There is no number smaller than 100 that can divide both of them. Okay. But can any number greater than 100 do that? Yes, all multiples of 100. So even 200 is fine. Even 300 is fine. Even 400 is fine. Okay. That's where this least common multiple, you want the smallest. So the smallest is 100. So 100 is the LCM. Okay. So basically concept wise, this is it. And LCM always will be equal to or bigger than the largest number. HCF, if you remember, was always equal to or smaller than the smallest number. HCF is always equal to or bigger than the biggest number. Okay. There are three methods of finding the LCM. First method is listing the multiples. Second method is prime factorization. Third method is divisibility. Let's look at all three of them. Prime factorization first, because that is what we did in HCF also. Same method works here also. So 20 is equal to 2 into 2 into 5. 25 is equal to 5 into 5. So factorization is same, but after this the method is slightly different. What you do here is you take the common factor. So 5 is common, you take 5. Then there is nothing common. Now whatever is left out, you take them also. First, if you see if it's common, you take them only once. If it is not common, you take them separately. So this 2 has nothing common, so I'll take 2. This 2 has nothing common, so I'll take 2. This 5 has nothing common, so I'll take 5. So you'll get 100. Okay, so this is the prime factorization method. Okay, then divisibility. In divisibility, what we do, we basically divide both of them together. 20 and 25, you factorize them or you divide them together. Start with the smallest prime factor, 2. If 2 is not there, then 3, then 5, and that's how you move. But you divide them only by prime factors. So I divide them by 2. And it does not matter if only one of them gets divided. If any one of them gets divided, that's also fine. So if I divide by 2, 20 will become 10 and 25 will remain as it is. Okay. I divide again by 2. This will become 5 and this will become 25. Now I can't have 2, I can't have 3. I will divide it by 5. So this will become 1 and this will become 5. I'll divide by 5. This will become 1 and this will become 1. You'll keep doing this till you have 1, 1. That all numbers reduce to 1. And this is your LCM, which is 2 into 2 into 5 into 5. Okay. So that's how you get this. Fine. So this is my second method, which is the divisibility method. And the first method, listing the multiples, is what I prefer, which is what we had done for HCF also. You basically look at 20 and 25, you look at the larger number and you look at multiples of this number. Okay, so 25 into 1 is 25. Does 25 divide 20? No. Then 25 into 2, 50. Does 50 divide 20? No. 25 into 3, 75. Does 75 divide 20? No. 25 into 4, 100. Does 100 divide 20? Yes. So 100 is the LCM. Okay, so you just check the multiples. Fine. So that is the answer here. Let's look at the second number also. We had taken 9 and 15. Okay, so if I do the multiple method, so 15 into 1, 15 no. 15 into 2, 30 no. 15 into 3, 45 yes. So 45 is going to be the LCM. So multiple is better, it's mental, you don't have to write anything and you can get the answer. Okay, then LCM of prime and co-prime numbers. For two different prime numbers, their LCM will always be their product, obviously because they don't have anything common, so the LCM is going to be the product. And for two co-primes, their LCM is always the product. Okay, so for prime numbers also the LCM is product, and for co-prime number also the LCM is product, because in either case they do not have any common factor. Okay, fine. Now that we have understood this, let's apply this to some questions to get a better understanding. So 12, 15, 24, which method will you use? Let's use all three just to get a hang of this. So first, let's do common division. So 12, 15, 24. I'll divide this by 2. So I get 6, 15, 12. Again by 2. I'll get 3, 15 and 6. Still I have 2 left. So 2. So 3, 15 and 3. Okay. Then 3. 1, 5, 1. Then 5. I get 1, 1, 1. So the LCM is 2 into 2, 4, 4 into 2, 8, 8 into 3, 24, 24 into 5, 120. Okay, this is one method. Second method, by prime factorization. 12 is 2 into 2 into 3. 15 is 3 into 5. And 24 is 2 into 2 into 2 into 3. Okay, now I look at, first I look at what is common. So 3 is common. So I have 3, 3, 3. So I take 3. Nothing else is common in all three of them, but something is common in 2 of them. So there is a 2 and there is a 2. So I'll take 2. Okay. So even if it's common in 2 of them, you'll take it only once. Then there is 2 and there is 2. So I'll take 2. Okay. Then there is nothing else. I have 1, 2 here. And I have 1, 5 here. So I'll take that. So 3 into 2, 6, 6 into 2, 12, 12 into 2, 24, 24 into 5 is 120. Okay. So I can use this method also. And then the third method, is my favorite method, which I told you, which is basically checking on the multiples. Okay. So what we can do here is look at the largest number, which is 24, and 24 into 1. Does it divide 12? Yes. So if it divides 12, then you don't have to bother about 12. Subsequently, 24 into 1, 24, does it divide 15? No. So this we already got a yes. So don't check for 12, because if 24 into 1 is dividing 12, then 24 into 2, 24 into 3, 24 into 4, all of them are going to divide 12. So just bother on 15. Okay. So then 24 into 2, 48. Does it divide 15? No. 24 into 3, 72, no. 24 into 4, 96, no. 24 into 5, 120, yes. So 120 divides 15, it divides 12 also, hence 120 is the LCM. Okay, so all three methods, whichever one you want to apply, it can be done. Let's do one more question. Let S be the LCM of the first 20 natural numbers. What be the LCM of the first 25 natural numbers? Okay, so after you have S, so you basically, we want the LCM now of S and 21 and 22 and 23 and 24 and 25, right? Because S is already up to 20. Now 21, if you see, is 3 into 7, and 3 and 7, both of them were in 1 to 20. So they already have been captured in S. So they will not add anything extra. 22 is 2 into 11. Both of them were already there in 1 to 20. 23 is a prime number. So this would not have come before. So this will come extra. 24 is 2 into 2 into 2 into 3. So you can say 8 into 3 or 2 into 14, 2 into 12, whatever. All these have come before. So they will not add anything. 25 is 5 into 5. Now 5 has come in 5, 10, 15 and 20. They all have 1 5. right? But 25 has two 5s. Second 5 has not come. So second 5 will come extra. So basically what will come extra is S, 23 and 5. So the new LCM is going to be 23 into 5, which is 115 into S. Hence the answer will be choice 4. Okay, so that is going to be the answer for this question, 115S. Okay, okay, let's move on. 5 bells ring at intervals of 1, 2, 3, 4, 5. It is seconds. Okay, seconds respectively. How many times would they ring together in a day? Okay, so to ring together, obviously there has to be a time which is a common multiple of 1, 2, 3, 4, 5. That means it has to be the LCM. Now the LCM of 1, 2, 3, 4, 5. How do you manually check? Let's check for 5. Multiple of 5. 5 does not divide any of them. 10 divides 2 and 10 divides 4. Then let's look at 15. No. 20. No. 25. No. 30. No. So what do I get? 35. No. 40. No. Is 60 the LCM? 60 seems to be the case. If you see factor wise, 1, 2, 3. Most of them are prime. 2 into 2 and 5. So 2 I'll take once. Rest everything I'll have to take 2, 3, 5. So 60, yes. So 60 is the LCM. 60 seconds, right? That means 1 minute. They will ring together after every 1 minute. So how many times would they ring together in a day? A day has how many hours? 24 hours into 60 minutes. That means 1440 minutes. So they are going to ring together 1440 times in a day. That would be your answer for this question. I hope we are clear. Okay, let's move on. 3 wheels can complete 60, 36 and 30 revolutions per minute. There is a red spot on each wheel that touches the ground at time 0. After how much time all these spots will simultaneously touch the ground again? Okay. So what you need to calculate first here, the 60 revolutions per minute is not what I need. I need how much time does it take to complete one revolution. So it completes 60 revolutions in, let's look at the first one, 60 revolutions per minute. That means each revolution takes 1 second. Okay, 1 second. Second one does 36 revolutions in a minute. Okay, so how many seconds does it take per revolution? You will have to do reverse of this. 36 revolutions in a minute. That means 36 revolutions in 60 seconds. And you reverse this, that means in 60 seconds it does 36 revolutions. That means it does 60 upon 36 or 5/3 seconds for each revolution. So this is 1 second per revolution. This is 5/3 seconds per revolution. And the third case, it does 30 revolutions per minute, which means 30 revolutions in 60 seconds, which is, now you reverse this, 60 seconds for 30 revolutions. That means it is 2 seconds per revolution. Okay, so we have these three values: 1 second per revolution, 5/3 seconds for a revolution, and 2 seconds for a revolution. And when it completes a revolution, then the red spot touches the ground. So we want to have a common number of revolutions so that the red spot for all of them are touching the ground together. So basically you need to find the LCM of 1, 5/3 and 2. Okay. Now this is LCM of a fraction. LCM of a fraction we will discuss in next slide. But just to tell you, LCM of a fraction is nothing but you take LCM of the numerators. So 1, 5 and 2, the LCM is 10. and you take HCF of the denominators. So the denominator is 1, 3 and 1. So 1, 3, 1, you take the HCF which is 1. So our answer is 10 seconds. Okay. So 10 seconds, if you see, this one would have done 10 revolutions, this one would have done 5 revolutions, and this one would have done 6 revolutions. So at the 10th, 6th and 5th revolution, they all would have completed a certain integer number of revolutions, and hence the red spot would have been touching the ground. So after how much time? The answer is 10 seconds. After every 10 seconds, all the red spots will simultaneously touch the ground. Okay. So that is the answer for this question. Yes, and this is what I was telling you. If you have to take LCM and HCF of fractions, then HCF of fraction is HCF of the numerators and LCM of the denominators. LCM of fraction is LCM of the numerators and HCF of the denominators. Very simple to remember. Whatever you have to do that for the numerator and do opposite for the denominator. So HCF, you do HCF of the numerator. LCM, you do LCM of the numerator. Okay, that's all. And just you do reverse of the denominator. Okay. Then if the ratio of two numbers, then couple of more concepts, and then we'll move on to some more questions. If the ratio of two numbers is A is to B, then the numbers can be written, and this is a very important concept. We are going to use this in a couple of questions also. If the ratio of two numbers is A is to B, then the numbers can be written as AX and BX. Okay, obviously, so let's take an example. Let's say 20 by 24. Okay, 20 by 24 can be written as 5 by 6. Okay. And actually the numbers will be 5x and 6x, right? Because what x is common, which has been cancelled. So 5 by 6 is the lowest common form. So the numbers are being written as ax, which is 5x, and bx, which is 6x. So the HCF of these two numbers is x. HCF is x. And the LCM of now 5x and 6x, what is the LCM? X is common, and 5 and 6 will not have anything common because they have been reduced to the lowest possible form. So 5 and 6, so it will be 5 into 6 into x. That is going to be the LCM. Okay, so the LCM of these two numbers is going to be 5 into 6 into x. And just to take this live example, x here, in this case, we know x is equal to 4, right? X is 4. So you can see that for 20 and 24, their HCF is 4 and their LCM is 5 into 6, 30 into 4, which is 120. Okay. Then product of two numbers is always equal to their LCM into HCF. Here itself, going back to this example, LCM was 5 into 6 into x, HCF was x, and the number was 5x into 6x. So you can see that you get 5 into 6, 30x square on the left side, and you get 30x square on the right side. So very important, product of two numbers is equal to their LCM into HCF, and if the numbers are in the ratio of A is to B, then ABX is the LCM and x is the HCF. Okay, let's apply this in some questions to understand this better. Okay, so let's first take a fraction. What is the product of LCM and HCF of this? Now, product, we can do this in two ways. First is you can find the LCM and the HCF. So let's find HCF. HCF of a fraction, 7 by 13 and 3 by 5 is HCF of the numerator, 7 and 13 HCF. There's nothing common, so 1. 13 and 5 LCM, again there's nothing common, so 13 into 5. So it is 1 by 65. Okay, LCM of 7 by 13 and 3 by 5. LCM of the numerator, 7 and 3, nothing common, so 21. HCF of 13 and 5, nothing common, so 1, so their LCM is 21. Now the question is product of LCM into HCF, so 1 by 65 into 21, or it is 21 by 65. This is the first method. The second method is, we just discussed in the last slide, that HCF into LCM is product of two numbers. So you basically do not have to find LCM HCF. Instead of finding this, I can find this, which is 7 by 13 into 3 by 5, which is 21 by 65. I'll get the same answer. So I can eliminate finding out HCF and LCM. And this obviously is better and faster. Okay. Next question. In a bookstore, the words of the glow sign board modern bookstore are individually flashed after 5 by 2, 17 by 4 and 41 by 8 seconds respectively. Each word is put off after a second. What is the least time after which the name of the bookstore can be read? Okay, so imagine that at some point of time, at the start or at some point of time, all three of them are flashing. Okay, all three of them are flashing together. Okay, they all remain on for a second and then they are put off. Okay, so now if you see, so modern, books, these are three, right? And store. So it flashes after 5 by 2 seconds and then one more second it remains on. So this is the total time after which it will flash again. So it has flashed after 2.5 seconds and then 1 second more, so 3.5 seconds are gone from the starting time. Similarly for books, 17 by 4 seconds, after it flashes after 17 by 4 seconds and it remains on for 1 more second. And for bookstore, it is 41 by 8 seconds plus 1 second. Okay, so this is the amount of time they are going to take to flash again. 5 by 2 from the start I am counting, so 5 by 2 plus 1 because 1 second they remained on also. So basically this is 7 by 2, this is 21 by 4 and this is 49 by 8. So basically they flash after every 7 by 2 seconds, 21 by 4 seconds and 49 by 8 seconds. And I want them to flash together, so the value has to be LCM of these three values. 7 by 2, 21 by 4 and 49 by 8. LCM of 7, 21, 49. You can see that 7 is common in all of them. Okay, 21 has a 3 extra and 49 has a 7 extra. Okay, HCF of 248 is 2. Okay, so you basically get 7 into 7, 49, 49 into 3, that is 147 by 2, which is 73.5 seconds. So they'll be flashing after every 73.5 seconds, or first will be the answer choice. Okay, so what is important here is this: each word remains on for a second, so that will get added. So you do not take 5 by 2, but you take 7 by 2. This 1 second you have to add, okay, because then the time taken to flash is not 5 by 2 but 7 by 2, because 5 by 2 plus 1, because your timer will start only after this 1 second has also passed, right? So basically it will be 7 by 2. Okay, great. Let's now move on. One concept that we discussed just now, in fact this is a recap of that concept, very important. LCM of two numbers, LCM and HCF of two numbers are this. Okay, so HCF is 9 and LCM is 90. Okay, so when the HCF is 9, and we discussed this just now, let's say the numbers are A and B. So when the HCF is 9, I can say the first number is 9x and the second number is 9y. Okay, so their HCF is going to be 9 and their LCM is going to be 9xy, which is given to me as 90. that means xy is 90. That means xy is 10. Okay, one important part. Second very important part also, that xy is going to be co-prime. Xy can't have anything common, because if there was anything common, then that would have gone in the HCF. So the only common part was 9. X and y are co-prime. So for xy to be co-prime and the product to be equal to 10, what combinations of xy are possible? It can be 1 and 10, or it can be 2 and 5. Right? So these are the two pairs. So if I put x as 1, okay, and y as 10, then my number a and b, that means a is 9, b is 90. Or if I put x as 2, that means this is 9 into 2, 18, and this is 45. So these are only two pairs possible, 9 and 90, and 18 and 45. These are not ordered pairs, so you might say that 9, 90, 90 and 9 is also possible. So that does not matter, because the question is not saying ordered paired, how many pairs. So one number is 9 and the other number is 90. It does not matter which is 9 and which is 90. So one number is 9, the other is 90, or one number is 18 and the other number is 45. These are the only two possible pairs. So answer is there are two pairs possible. Okay, so very important, one more part to understand is that this x and y, they have to be co-primes. They are co-primes. And when you look at that, then this becomes very easy. Okay, great. One more question. If p is a prime number, then what is the LCM of p and p plus 1? Now this, if you remember, we had discussed some time back that p and p plus 1 are consecutive numbers, right? P and p plus 1. And consecutive numbers are always co-primes. And co-prime numbers, their LCM is their product. So the LCM obviously of p and p plus 1 is going to be p into p plus 1. As simple as that. That is the answer. For example, if you look at 20 and 21, 20 and 21, their LCM is 20 into 21. As simple as that. Okay, so this is the answer. Okay,